So 8, 7, 6, there we go.
Can you see my slides?
Yes, indeed, we can.
Okay, so
Yes,
thank
we're
you very
gonna
much
hold on, hold
okay.
on one sec. I'll introduce you and then we go for
Okay.
the talk. Just one sec. Hello, everyone. Be welcome to the first talk of our conference of Quantum Latino 2022. Professor Luis Alberto Muñoz Ubando is a very old friend of mine and a fantastic scientist, and we're very proud to have him around as the first speaker of our conference. Professor Muñoz is a professor of computer science at Tecnológico de Monterrey, Campus Monterrey. He's got a very, very long academic history. He read for BSc in Electronic Systems at Tecnológico de Monterrey, Campus Estado de México. Then he went to France. He read for a Diplôme d'Études approfondies in computer science and applied mathematics in order to later on get a PhD in robotics, automation, and computer vision at the Institut National de la Recherche Informatique et Automatique. After that, he's had a number of postdocs in many places, Austria, at the University of Vienna, at the University of Oxford. He also has quite an interesting career in industry, in the development of applied research. And well, I think that if I kept on talking about Alberto CV, we actually be basically delivering the lecture myself. So I'd rather pass it on to Alberto. Be welcome. Thank you very much for being here.
Thank you very much, Salvador. It's a pleasure for me to be here today. So today I will try to give you some ideas about how quantum computing is actually offering several challenges for robotics and automation. I do really apologize at a certain moment. I will try to use a Spanish word if I have some problems with the techniques details, but I will try to follow it in English and spend the rest of the 30 minutes with you. So, of course, when we talk about robotics and automation, we actually used to have these kind of images when the people are a little bit scared about the use of technology for basically automation and something that can be in a way to replace human beings in several activities. With the pandemic, nevertheless, we had the disruption of robotics for several kind of services, as on health, and as well on automation of retail. And we have a boom or explosion on the requirements for robotics, autonomous robotics, basically on providing services to help people about the everyday activities. So as you perfectly know, when we talk about the quantum world and quantum computing, actually, we have to take into account that maybe the two most important algorithms that succeeds to create a disruption on the research. It was, in one side, the proposals of Professor Peter Shor, about the quantum Fourier transform, that for us, the engineers doing robotics, we used to deal every day on image processing, on dimensionality reduction, singular value decomposition, and Kalman filtering, and so on. All the time, we are actually using Fourier transform and fast Fourier transform in a numerical way. And as you are aware, actually, we are moving to the 5G and in the near future, 6G world, when we are going to have Internet of Things connection of almost everything. So you can perfectly imagine the importance that we can have in automation with the incorporation of these kind of quantum approaches as the one proposed by Peter Shor. In the other side, we have another kind of research utilities we use in robotics that are basically related with motion planning and so on. So as you know, Professor Love Grover that proposed several ideas on how to use quantum computation for improving searches. So it's now a common utility to deal as an introduction on quantum computing with these kind of approaches. So we have seen two of the most important ideas on robotics. One is the signal and image processing that used to be taken into account for feedback in motion in robotics, and as well how we can perfectly planify the strategies for a robot to move around a set of obstacles, or if we like to optimize paths. So we have processing for feedback, and we need to planify motion in robotics. So we have immediately connected with the quantum computing world with those ideas. And now we have this disruption on the use of technology, of course. And as far as we are actually moving in trying to incorporate these kind of technologies, we have to take into account how fast the technology is actually moving. So it's not a joke saying that in the near future, maybe we will have, as an example of those very powerful quantum computers that we are actually trying to get to our desk in the near future, that should have something similar to which will be the advantages of this miniaturization of the technology, and we can take it as an asset for robotics and automation. So when we talk about the industry 4.0, we have several approaches, starting for autonomous robots. We all try to look for solutions in such a way basically to avoid accidents. So that's the main inspiration for autonomous robots. So we need communications, we need to planify motions, we need to analyze images. The next step on the right, we have simulation. So we have to improve the way we can perfectly simulate very complex systems. So we need to improve the way we are using computations. We have on the left big data. So we have more and more data gathering for our resources and Internet of Things. And we all need to get and process those information with artificial intelligence, with data science in such a way to improve the way we can gather information and processes. Now we are moving, there are several movements on the metaverse, so we can improve augmented reality. And in such a way to do so, we have to improve the way how we are providing information in real time to eventual lens in which we can interact with several virtual objects. We are improving the way to use additive manufacturing. We are dealing as well on the use of new methodologies to create and discover new materials. And as well, we have to increase the use of computations. We are now connected to the cloud, and we need to overcome eventual threats to our communications. We need to improve the way how we are dealing with cybersecurity. And at the end, we are actually moving in that way in which we are looking for the simulation and the system integrations. So as we can see, with only those two small, very huge impact algorithms improvements on the quantum world, one with optimizing paths and trajectories, and in the other with the image or signal analysis with the Fourier transform, we are going to be expecting a huge change on robotics and automation in that side. Several years ago, Salvador started teaching us a lot about quantum computing, and we start dealing with how we can improve those complex approaches on motion planning, and we start thinking about how to use quantum computing algorithms for improving motion planning on dexterous manipulation. So this idea that we can use robotic hands or eventually improve the way how we can use several use of robotics in such a way to overcome restrictions and uncertainty related with the processing of the information. So now that we have this technology improve on, for example, FPGAs with a very small size electronics, we can actually deal with the traditional algorithms on such a way to, for example, tracking objects on industry. So in that way, we are actually just dealing with the model-based systems. But if we like to improve the way of tracking, for example, flexible objects, that it appears to be the most common sense on industry and the common case as well on the services, we have to improve the way we are actually dealing with those kind of computations. So we are actually dealing with a consolidation of those ideas of using this small size electronics. So, and we are of course looking to improve the way how, as far as we are actually moving to making a miniaturization of these electronics, we are going to be having these kind of effects related with the quantum physics. So as far as we are moving to this idea of improving electronics, so we can improve the way we can run on perception, localization, planning, and learning. As you have testimonied during the last 20 years, we have an improvement on the uses of machine learning and deep neural networks and so on. And we are actually dealing with this idea of trying to model in black boxes in such a way to better understand very complex dynamics. So this is the kind of dynamics we have actually in robotics. And of course, on research, we have several challenges that, of course, they can be improved by the use of these microelectronics that in the near future are going to be composed with the facilities provided by quantum computation. For example, what we can do now, actually, this is the kind of research I'm actually doing with my students, in which we are trying to prove the way how, for example, those robots can really interact on several services, providing by analyzing images and improving the way how we can deal with several spaces when we have almost no knowledge. And we can see on the right that we have to start creating those behaviors only by using and gathering information. We can see here at the middle the perception of the cameras. That, of course, is the kind of classical computations that we are actually looking to improve and starting defining those quantum algorithms that in the future can be useful. But as well, we can start dealing and playing with the simulation of those algorithms on those real applications of robotics. We can imagine, for example, those kind of necessities when the people, for example, can be in one side teleoperating those systems, and in the other side we have to be gathering information, processing data, and at the end what you like is that the robots can interact with the behavior. And for example, in these cases we are organizing how can the robot grasp those objects and eventually allocate them in a very organized manner until the end we can reach and analyze the position. So those are actually the kind of restrictions we have. We have to improve the velocity, to make it faster, to use real behaviors to analyze images, to improve the way we are actually computing the Fourier transform in several layers. And as well, we have to improve how we can deal with more complex behaviors for planning and manipulation. So those are just the kind of examples in which we can start working, for example, on telecontrol. What we have actually of the hugest impacts on health is the use of this kind of robotics when you have an expert dealing with a teleremote control of a surgery, but at a certain level you have to improve that in an autonomous manner. So we are actually working as well on how we can improve the way on which we can deal with the automation of those kind of processes. For example, we have to use cameras in such a way to allocate, for example, the needle on that challenge. And the idea is that we can identify where the needle is. And for example, we just last Monday submit our solutions to this challenge in the AxelNet in Johns Hopkins University, when we were providing solutions in computer vision to identify where we can grasp, for example, the needle in an automatic manner. So for example, here we are going to see how we are actually dealing with the processing on those images. And you can see how we are actually tracking almost in real time after a machine learning approach on how to determine where the needle is. So of course, if we like to improve the way we can deal with these kind of approaches, we have to improve as well the computation. And this is an example for the first challenge. The second challenge is once you have the needle grasped with the robots, and supposing that you have uncertainty on the position, you have to deal as well with to reducing the amount of information you have to deal for processing when the needle is already grasped in such a way to planify how to carry on the searcher and on a strategy. So you can see how we are actually dealing with these ideas on improving the way on doing computer vision, image analysis, motion planning on those kinds of ideas that can be do it not only remotely, but that more we are actually moving for the automation of these kind of processes. And of course, the challenge is that we don't really like to be in that situation if we have uncertainty of if the robot is actually coming some mistakes on the motion planning and neither on the image processing. We don't like to be here in that case if we have some cyber threats or we have some problems with the robot. So we obviously, if we like to reduce the cost of these kind of surgeries, do it with robotics. We have to improve the way how we can deal with the motion planning. In the other side, we have several companies as Deloitte, who is a consulting firm that is actually analyzing and is proposing the three main quantum use cases for computing, communication, and sensing. And as you can see, we are start having this kind of convergence on approaches from the industrial size. We have a lot of very appealing subjects what we are going to see in the near future, a lot of investment on research and technology development. So it's a very good moment in which we can really optimize the paths to have a shortest time to improve the technology we are dealing with on robotics and automation. And we are not alone. We are many people dealing with these kind of approaches. For example, on cybersecurity, we are dealing with a disruption of papers in which they are analyzing how we can deal with the most important issues of threats that can be related with security issues, with the lack of security, with the lack of authentication, the lack of confidentiality, that we can have problems of malicious manufacturer and so on. And of course, we have, as a consequence of these kind of causes, if we don't provide the correct governance of the data, is that we are going to have backdoors. We can have device from thieves. We are going to have unencrypted backups in these kinds of faking world where we are actually going, if we are not taking into account the advantages of using cryptography based quantum algorithms in such a way to overcome those kind of challenges. So the idea is that we can improve with those algorithms the way we can protect both hardware, the firmware, and of course the layers of applications. So now we have more and more ideas on how we can, for example, enhance the basic restrictions we have on machine learning with quantum approaches. So we have several ideas of different architectures that we can use to improve the circuits, because at the end, the near future quantum computers, we are going to have a combinations, as you know, classical computers and quantum gates or quantum units that we can improve with the system, with the circuits. So at the end, we are going to have a combination, but we have to start dealing with how we can start really incorporating this kind of intelligence in the robotics based on quantum software engineering. And we have many ideas on, for example, as well, how we can improve the cooperation, communication in between several agents. So we have a traditional approaches of multi-agent systems. We can communicate between them, and as well, they can take decision in teams. And we have, for example, this is the best approaches for start dealing with Q-learning. When we are actually teaching students multi-agent intelligent systems, we can start providing them this idea on how you can change the algorithms taking into account quantum computation. So, and as we are actually moving with this Internet of Things world, and we can improve security, we can start dealing with taking into account quantum layers. When we have a quantum security layer that can help to improve the communication in between the actors. And at the end, the idea, as you have maybe realized already, is that we have a very promising approaches on how we can improve the use of using robotics in combination with quantum ideas. So for example, as well, we have a lot of ideas on how to improve the autonomy of vehicles on these cyber physical security layers, when we can improve the way how we can use the capabilities of those approaches on quantum algorithms in such a way to overcome uncertainties, and how we can really improve the way on decision taking for robotics that can eventually incorporate, for example, moving obstacles or some kind of uncertainties on the way how the robots are evolving on the space. So we have another approaches. We have several support for the state of the art. So it's very important to know that the quantum computing and robotics as a science and applications have been very appealing. So we have several methodologies, and as well, we are actually having some ideas on how we can improve the quantum computation with classical mechanical apparatus. As you know, it is very important to start understanding how we can improve the way to carry on experiments, even with Legos or other kind of robotics. For example, those friends in Tel Aviv, they're actually dealing with a kind of quantum decision making on robotics with toys. So they are improving ultrasonic sensor, touch sensors with this kind of algorithms in simulation. And it's very interesting how the people start realizing the new ideas for the near future of robotics with quantum approaches. So we are very lucky that those times we have several state-of-the-art explanations on how, for example, this disruption of reinforcement learning can be improved with this transition from classical computation to quantum approaches. So the idea is that we can really incorporate parameters, that we can incorporate representations of the entities that we are actually dealing as I just mentioned. For example, Q-learning is something that can be very easy explained in terms of quantum computations. For all those who know maybe about control systems as well, because at the end, the robotic is something that we have to deal with the control engineering behind. It's a combination of robotics and mechatronics. And as you can see on the left, you have the traditional approaches for control. Maybe you can recognize the PID, the traditional proportional integrative derivative around the error that we can compute with a sensor. But at the end, we can as well improve the way how we can use, for example, fuzzy relationships on the approaches. So this is a traditional problem when we like to maintain the inverted pendulum on the robotic. This is something that I used to use a lot with my students to start dealing with non-differential equations when we have to deal with kinematic restrictions. And this is a very nice example I'm actually using with my students, such a way to give them an introduction to quantum control, when we can start dealing with a way to define the space of search with the quantum algorithms, and we can deal with those approaches going to the landed on robotics. So as well, we have several algorithms. For example, the particle swarm optimization algorithm, that is a traditional approach that we start dealing at the end of the century with using several particles to represent complex systems on computer vision and motion planning. And now we have those new versions of the algorithm. So it's very interesting to start analyzing how we can have these transformations of approaches when coming from the traditional algorithms, that we have some complexity analysis and how we can translate those problems to start dealing with the quantum approaches with those very well-known algorithms we use on robotics. So there are several ideas in fact, on the language we can use to deal with those problems. And of course, we can characterize in terms of adaptation and the degree of complexity in robotics, in which we can, for example, for the robot motion, deal with complexities on singularities on the invert kinematics approaches. For example, we can decompose tasks, we can have trajectory variation, and of course we can deal, as we are increasing the complexity in between this wall between the continuous solution to the discrete solutions, we can as well support, for example, robot design. So the most interesting ideas actually is those for some of my friends who are actually dealing, in fact, with the quantum software modeling. So robotics and automation are actually concerning in how we can improve the best practices in dealing with the software we are actually dealing. So it's very interesting that we are start having those ideas on how we can create software modeling that can be used, of course, for robotics and other kind of applications. But we can start having these ideas on how we can translate from one world to the other in terms of software. And of course, about blockchain, as the works coordinated by the Inter-American Bank, in which Professor Venegas participated recently last year, in which we have, for example, this disruption of blockchain incorporated for overcome threats and how we can use quantum resistance. So we have several approaches, several ideas in which we can improve the technology on dealing with robotics and automation. This news appears just last Monday at Nature. So the idea is how we can improve of the advantages of quantum computation with photonic processors. So we have more and more ideas on how we can at the end eventually deal with this kind of technology that can reach and help us to reduce and create prototypings, and of course to reduce uncertainty. So we have several efforts around the world, and I think that is an exciting moment in which we can look for this convergence, in which we can overcome several of the uncertainties and questions we have on the past, if it is going to be possible or not. We start dealing to create these software computing approaches to move from the traditional world to the quantum world, and we have a leitmotif on robotics. So the idea is how we can start talking with the robotics and between the people in such a way to overcome those potential threats of automation. And we have to start defining this communication wall in such a way to improve the quality of life. And I'm sure that in the near future is very promising if we push very hard in the incorporating of quantum technology for robotics and automation. I'm stop here. If you have any question, I'm sorry if I speak a little bit fast, but I really like to be on time with a compromise. Thank you very much for this opportunity.
Thank you very much, Alberto. It was a fantastic talk. I appreciate it, and I'm sure we all are grateful for your words and your approaches towards quantum computing and the intersection of this discipline to many others. So I can see no questions on the chat, but I have one, which hopefully can be answered in a minute, which is, what are your views in terms of the say intersection of computer vision and quantum computing? What would be sort of the first potential research lines or areas that could actually be analyzed, studied, researched over the next few years?
Well, I think, one of the main problems we have actually is on tracking. Tracking is a very, very well-known and straightforward solution on using CAD models that are rigid in general terms. So there is no flexibility on the object, and you can discretize the space. So one of the most appealing approaches now in industry, and in fact on robotics for services with people, in which we incorporate real life events, are dealing with the simulation and the manipulation of flexible objects. So in such a way to do so, you have to use cameras in such a way to observe what is actually happening and try to estimate the actual position of the particles in the flexible world. I think that is one of the most appealing problems now in the industry. And of course, in one side, those technologies pulled by the industry and pushing from the academia. So I think that we, at the middle, we are both concerned on the extension of the actual technology that we can use on dealing with flexible object tracking and manipulation. I think is one of my main objectives in the near future, dealing with this kind of approaches. And I hope that we can incorporate quantum algorithms in such a way to improve the way we can deal with those kind of problems.
Okay, thank you very much for your answer. Well, that's it, I'm afraid, because we have to move to the next session. So thank you very much again for being with us.
Thank you.
So it was a pleasure, and see you around.
See you then.
Thanks. So now for everyone, please move to the session. It's going to start in a minute with Professor Analia Zvik. Thanks a lot.